What's good, y'all? It's your boy, Rashawn.
And your boy Josh, and we're here to talk to you about thermodynamics.
Thermodynamic system does work. It loses heat, and when work is done on the system, it gains heat. So heat is converted to work, and work is converted to heat. Work and heat is transferred into or out of the system represent the change in its internal energy.
This idea that the change in internal energy is equal to the change in work plus the change in heat is so fundamental that it's known as the first law of thermodynamics.
What?
So we can have an equation to use for analysis problems. So what we would write is internal energy of U of the closed system is equal to Q, and the heat transferred to the system, minus W, the work that is done by the system. It's important to remember, if we talk about change in internal energy, if the heat is transferred into the system, Q is positive. If the heat is transferred out of the system, Q is negative. And if the work is done on the system, W is negative.
This right here is an AC. This right here is an AC. Ooh.
Tell us about that AC.
Yeah, man, I got you. This is a basic illustration of an AC unit. AC units usually use a coolant called Freon. We will start at the compressor, which is represented by the W inside the square. The compressor compresses gas and transfers it into the valve. Right there. And oh, my fault. I got something in my throat. My fault, y'all. You know, it's crazy. But anyway, from the valve, it will go to the outside of the AC. Heat or Q transfer the Freon to the tube and from the tube to the air, which cools down the Freon and in turn releases heat into the air. This is the air, y'all. This is the air right here. This liquid travels up the tube. Up the tube all the way to the expansion valve, which is right here. So let you guys see that. The expansion valve turns the liquid into a gas, and this gas or vapor is what travels to the AC unit. Yep, right here. Y'all see this? All gas over here. Which, oh, my fault. This vapor or gas go all the way down. This vapor? Alright, yeah. This vapor or gas go all the way down to the compressor, where it is compressed and then into a liquid again. This process is repeated multiple times, over and over and over. But as it's being a gas, it comes to the compressor, and which is energy, and it needs energy because you need to plug this up into an outlet, which is basically how the AC works. What are you doing?
Hey, bro, chill out. You know I ain't got nobody for Valentine's Day right now.
Do this.
Hey, bro, you trying to kill some crackers?
What?
Some crackers.
Oh.
This right here, I don't know if you know this, but that's a freezer and refrigerator combo, boy. Bet you ain't seen it before. Right? Bow. Ooh. Bow. Ooh. Bet you ain't seen the dual screen action on them. Look at this. It's nice and cold, you know, crispy. That ain't me, by the way. That's that. Right here, extra cold. Boy, look at that. Ice cream on the nips. Bet you ain't know. So, this is the simplest illustration of a refrigerator, which is also the same one as the AC. So, what happens is the refrigerant. All right, we'll start at W, which is work in the compressor, right? So the liquid or the gas that is coming out of the refrigerator goes into the compressor. It starts to become compressed, which turns it into a liquid. So as it's becoming a liquid, it's being pumped in through the piping, which leads to the valve. From the valve, it gets pumped outside of the refrigerator, which transfers Q, which is heat from the refrigerant to the piping to the air, which cools the piping, which cools the refrigerant. So it travels up. This is a liquid, by the way. The liquid travels up, reach the expansive valve. So the expansive valve, what it does is it takes that liquid and expands it into gas, and that gas or vapor travels through the piping within the refrigerator and sucks in. Since this is cool air, it sucks in the energy, which is the heat from the refrigerator, which is Q, into the piping. And so the piping, that energy and that heat gets to the refrigerant. Refrigerant starts working its way back down to the compressor, and the whole cycle starts again. And it just keeps going, and keeps going. So back to it. At W, which is going to be our compressor, there needs to be a energy to make everything work, which is the outlet. So it's plugged up to something. I wish I could pull this out for your class, Mr. Palmer, but I'm not going to do that. That's a lot of work, and I'm fat. So as you can see right here, it shows from the inside, heat to tube to refrigerant, and then as it works its way out, it goes from refrigerant to tube to air. And that's how we tie it all together. The last one we're going to do is the ice. Now the ice is a piece of frozen Kool-Aid, which is at around 32 degrees. And so the air in here is about 75 degrees. And so the 75 degree air is hitting the plastic, which is warming up the ice on the inside.
Now my body heat is at 98 degrees. So the heat from my hand is going into this plastic and into the ice, which is helping melting the ice. This is an example of thermodynamics.
Thanks for watching.
This is Rashawn.
And your boy Josh. Have a good day.